let's continue now to liquid containers subjected to constant rotation, which is in fixed rotation. Let us see. An open cylindrical tank, 50 centimeter in diameter and 3 meter high, contains water up to a depth of 1.6 meter. So you have 3 meter high cylindrical tanker, but the container has a fluid or water up to a depth of 1.6 meter. So if the cylinder rotates about its vertical axis at a speed of 250 revolution per minute, determine the height of paraboloid formed at the free surface and determine also the speed of rotation required for water to just start spilling, and determine the total pressure force on the bottom of the tank and side walls. So let us see. You have, this is a sketch. This is a fixed rotation with angular speed of 250 revolution per minute. Then the water level definitely will be declining to this direction, which is just a parabola form. So what will happen? What is y, which is a drop in this level, but initially it was full. And you have elemental dr. You can just calculate again using calculus or other approach. You can differentiate. Then finally you can find the result. So you can see this alignment again. So total r, you have r at what r distance. You can compute again. And z, this is z direction, this is r direction. So this elevation, you have free surface, you have then h naught, and then finally what is the level, or at what level you can just compute. So just axis of rotation is this one. It will rotate like this. So finally, what will happen? Let us see. So the initial step to do this problem, you have to just correct some system of measurement, and also you have to change the revolution per minute into rad per second, so that it will be just compatible. Let us see. So the solution is clear. The solution is clear. First, identify the given parameters. D, diameter 0.5 meter, then radius will be half of 0.5, it will be 0.25. This is x distance, at x distance. And h1 is the first depth of water given, 1.6 meter, and h2 is 3 meter. Then n 250 revolution per minute, then change rpm into rad per second. So rpm to rad per second should be converted. So this is omega. Omega is equal to 2 pi n over 60. So this is just to convert minute into second. So this is 2 pi for rotation, but you are given 250 revolution. So you have to just convert what portion of the 360 rotation will be. So 2 pi times 250 over 60. Then once you have this, then you convert into rad per second. So this is omega, angular velocity. So I think once you get angular velocity, you can find tangential velocity. Tangential velocity also can be computed, which is tangential velocity Vt is equal to omega times r. Okay, so the height of paraboloid formed at the free surface is given by this equation. It is derived from just the differential equation, which is just at what r distance from total r you can find. So at x distance, at this distance, then what will happen? What will be the drop in elevation of water? So 26.18 square plus x square over 2g, you get this. This is the paraboloid, the height of paraboloid formed. So the second problem is for water to just spill, the water will just touch the top of the rim of the tank or cylinder. So once it touches the rim of the tank, water will start splashing or overtopping. So thus the rise of water above the original becomes the rise of water above the original becomes H2 minus H1. From the total 3 meter, you subtract 1.6 meter, then you have 1.4 meter. So this is just the rise of water above the original. Then just Y will be computed. Y is twice of this one. So it will be 2.8 meter, 2.8 meter. Then once you get this value, so that it will start overtopping or just spilling, then it will substitute here in the equation. In the equation, just y 2.8, once you compute here, 2.8, then omega square times 0.25 square over 2 times 9.81. Then you get, this is omega, which is 29.65 rad per second. So in revolution per minute, you can convert again. Omega is given by 2 pi n over 60. So n will be computed in revolution per minute. So you have this revolution per minute. This is just conversion of revolution per minute using this equation. This is a general equation, how to convert just revolution per minute into rad per second. Okay, the total pressure force on the bottom will be equal to the total weight of the water in the tank and is given by this one. So the pressure force at the bottom of the tank you can compute. So at the bottom of the tank is you have weight. Just weight means gamma times volume. Then gamma means rho times G since it is water. Then volume is just volume of the cylinder. Volume of the cylinder, base area times height. So base area is pi r square. Then H1. H1 height you have. Then you get this result. So this is just the force, pressure force at the bottom of the tank. And total pressure force on the side walls will be equal to the horizontal force, which is like hydrostatic force, acting at the center of the height of the cylinder. So just you have total rho G, then 2 pi r. 2 pi r, which is this is cylinder, for example. If this is cylinder, then you have lateral surface area. So lateral surface area of this cylinder is, first you have circumference. Circumference, if you multiply by h, you will get what? Here you have r. This is circumference of the base of the cylinder. Then if you multiply by h, you get lateral surface area. It will be converted into this one, like this. It will be converted into rectangular cross section, which is just like it will be converted into rectangular cross section, something like that. Clear? So you have h, but this is from circle to 2 pi r. 2 pi r. So this is the total lateral surface area. So 2 pi r h lateral surface area, then times h2. So just gamma, which is h bar times area force. From the hydrostatic force, we know this one. Gamma, which is rho times G, gamma, which is area times h bar. H bar times area. So this is the formula. So we are using the same formula. So you substitute all values already given, then 1.6 over 2, then you get this. This is the total pressure force on the side walls of the tank. So I think this is all about liquid container subjected to fixed rotation. If you have any question or comment, please just give us. Thank you very much. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section below. I will definitely reply on it. So please like, share this video with your friends and subscribe to my channel to get more videos on similar examples. Thank you very much for your attending.